Before we do numericals related to error analysis, let's revise all the formulas related to error analysis. The first one here is the A mean. If we have number of measurements like A1, A2, A3, so on till AN, then A mean is equal to A1, A2, A3, A4 plus AN divided by N, or we can write the A mean as this also. Second is absolute error, which is equal to true value and the experimental value. For N measurement, we have the absolute error for A1, which is equal to A mean minus experimental value, which similarly we have delta A2, the absolute error in A2, and delta AN, which is the absolute error in nth measurement. Next we have mean absolute error. The mean absolute error is equal to the mean of all the absolute errors of the measurement, which is delta A1 plus delta A2, so on till delta AN divided by N. So we can write that the mean absolute error like this also. Next we had the measured value of A, which is always lies between A mean and delta A mean. So its value we can write like this: A mean plus minus delta A mean. Next we have the relative error, which is equal to delta A mean divided by A mean. Percentage mean error, which is equal to relative error multiplied with 100. So here 100 will come. So delta A mean divided by A mean multiplied with 100. Next we have combination of errors. If A and B are two physical quantities with absolute errors delta A and delta B, A error of a sum or a difference, the absolute mean error delta z is equal to A plus B here is equal to delta A plus delta B. So similarly for the this is for sum and difference. Now we have the error of product or division. Here we take the relative error. So delta z divided by z is equal to delta A divided by A plus delta B divided by B. So similarly, error in case of a measured quantity raised to the power, then z is equal to A raised to power A and B raised to power small b, then the maximum relative error in this case also will find the relative error, which is equal to delta z upon z is equal to, now this the power will come here multiplied with the relative error of A. Similarly, plus sign will come. If we have multiplication, then here the plus sign will come, then this power will come front and the relative error in B. So this is the maximum relative error in Z. You have to remember all these formulas by heart, then only you will be able to solve the numericals. Now let's get started the numericals. So first problem here, I have taken the lengths of two rods are recorded as L1 is equal to 25.2 plus minus 0.1 centimeter and L2 is equal to 16.8 plus minus 0.1 centimeter. Find the sum of lengths of two rods with the limit of error. So let's see how we solve this. This is related to the error of sum or difference. So here we know here it is given that the length L1 is equal to 25.2 plus minus 0.1 centimeter and L2 is equal to 16.8 plus minus 0.1 centimeter. So here we have to find the sum of lengths of two rods with limit of errors. So L1 plus L2 is equal to 25.2 plus minus 0.1 brackets close plus 16.8 plus minus 0.1. So we'll add these two. So if we add 25.2 plus this 16.8 and this plus minus 1 brackets 0.1, this plus this 0.1. So here we'll get, we add these two, we'll get 42 and this will become plus minus 0.2 centimeter. this is the sum of the lengths of two rods with their limit of error. So second problem is a potential difference of V is equal to 100 plus minus 2 volt when applied across a resistance R gives a current of 10 plus minus 0.5 ampere. Calculate percentage error in R given by R is equal to V upon I. So this is the formula for the resistance when voltage and current are known. So here in this question it is given that the voltage is equal to 100 plus minus 2 volt and current is equal to 10 plus minus 0.5 ampere. If we see this formula, we know this voltage is always this 100 will be equal to V mean. This is equal to absolute error in the voltage, which is equal to delta V mean. Similarly here this will be equal to the current, the mean current, which we represent with I, and this is equal to 0.5, which is equal to delta I. So here it is given that R is equal to V upon I. So voltage is equal to 100 divided by current, which is equal to 10. So R will be equal to 10 ohm. Ohm is the unit of resistance. So let me mark this as equation number 1. Then the relative error in R. The maximum relative error in R is equal to delta R upon R. So which formula we are going to use here? So as R is equal to V divided by I. So here this is the division of two physical quantities. R is equal to the division of V and I. So therefore the relative error in R is equal to delta R upon R, which is equal to the sum of the relatives error of V and I. So delta V upon V plus delta I upon I. So relative error, the maximum relative error in R is equal to this delta V upon V. Delta V is equal to 2 and V is equal to 100 plus delta I, which is equal to 5.5 divided by I. I is equal to 10. So now we'll solve this and we'll get this is equal to 0.02 plus 0.05. If we add these two, we'll get 0.07. So this is the relative error in R. So here we have to find out the percentage error in R. So the percentage error in R is equal to delta R upon relative error in R multiplied with 100, which is equal to 0.07 into 100. So this is equal to 7%. So this is my answer here. Next is a problem number 3, and this is very important problem. So here you will be able to know how we can find out the mean value, absolute error, mean absolute error, relative error, and the percentage error. The given problem is, in an experiment, the value of reflective index of glass was found to be 1.54, 1.53, 1.44, 1.54, 1.56, 1.45 in successive measurement. Calculate the mean value of the reflective index of the glass, absolute error in each measurement, mean absolute error, relative error, percentage error, and also express the result in terms of absolute error and percentage error. So let's get started. So these are the given values of the reflective index of the glass. Now we have to find the mean value of the reflective index. So we know the formula. What is the mean value of the reflective index? We represent the reflecting index with mu. So mean is equal to the sum of all these values, A1 plus A2 plus A3 plus A4, A5 plus A6 divided by 6. Okay, now we'll put all the values here. I have put all the values here. Now we have to add them and we have to divide that addition with 6. So we'll get here 1.51. So this is the mean value of the reflective index. Next we have to find the absolute error in each reflective index. So we know the absolute error is equal to mean value minus measurement value. So we can find out the absolute error for delta A1, which is equal to delta A1, which is equal to mean value, which is 1.5, minus A1, which is equal to 1.54. So this will be equal to minus 0.03. Similarly, delta A2, which is equal to A2 is mean value 1.51, minus A2 is equal to 1.53. So this will become equal to negative sign will come, minus this 0. Next, similarly, delta A3, which will be equal to mean value, which is 1.51 minus this 1.44. If we subtract them, we'll get 0.07. Here plus sign will come. Similarly, delta A4, which will be equal to mean value 1.51, subtraction 1.54, which will be equal to minus 0.03. Similarly, delta A5, which is equal to 1.51 minus this 1.56, this will be equal to minus 0.05. Delta A6 is equal to 1.51, subtraction 1.45. So here we'll get, if we subtract this, we'll get 0.06. So these are the absolute errors in different measurements. So next is the mean absolute error. So mean absolute error in reflective index is equal to delta A1 mode plus delta A2 mode plus delta A3 mode plus delta A4 mode plus delta A5 mode plus delta A6 mode divided by 6. So we'll put the positive values of all these absolute error, which is first one is 0.03 plus 0.02 plus 0.07 plus 0.03 plus 0.05 plus 0.06 divided by 6, and we'll solve this. We'll get 0.26 divided by 6, which is equal to 0.04. So this is the mean absolute error in the reflective index. So next is relative error in the reflective index, so which is equal to delta nu upon nu is equal to the mean absolute error divided by the mean value. So which is equal to, this is equal to 0.04 divided by the mean value, which is equal to 1.51. If we divide these two, we'll get 0.02649. So approximately we'll take 0.03. Next we have the percentage relative error. So percentage relative error, which is equal to delta mu upon mu into 100, is equal to 0.03 multiplied by 100. So this is equal to 3%. Now we have the last one. So we have to express our result in term of absolute error and in term of percentage error. So we can represent this first one is the result in term of absolute error. We know we always represent our result mu is equal to mean value, which mu mean or simply mu. So here mu mean is equal to, how much is this? We got 1.51 plus minus, how much we got this? The relative error, this mean absolute error, which is 0.04. So this is my answer in term of absolute error. So next my result in term of percentage. So this will be equal to mu mean plus minus, here we have to write percentage error. So mu mean is 1.51 and the percentage error is equal to 3%. So this is my answer. Last problem here is the centripetal force is given by F is equal to mv square upon r. Here it is given that the mass is equal to 0.5 kg, v is equal to 10 meter per second, and radius is equal to 0.4 meter. If mv and r are measured to accuracies of 0.05 gram, 0.01 meter per second and 0.01 meter. Find the percentage error in force acting on the body. So we have to find out the percentage error in the force. So here the formula is F is equal to mv square upon r. So it means the relative error in this force F is given by, we'll use the formula directly. So this will be equal to delta F upon F is equal to delta M upon M, plus here we have 2, according to the formula this 2 will come here, delta V upon V plus delta R upon R. This is the relative error in force. Now we'll find out the relative error in mass, in velocity and in radius. So everything is given, just we have to put all the values. We know the percentage error in F is given by delta F upon F multiplied with 100 is equal to delta M upon M multiplied with 100 plus 2 times delta V upon V into 100 plus delta R upon R multiplied with 100. So here it is given that delta M is equal to 0.05 and mass is equal to 0.5 m multiplied with 100 plus 2 times delta V. Delta V is given 0.01 and V is given 10 meter per second into 100 plus delta R, which is given 0.01 divided by R, 0.4 multiplied with 100. So now we have to solve this. We can solve this and we'll get 5. Here we'll get 5 divided by 1000 multiplied 5, and this 10 will goes up multiplied with 100 plus 2 times into this I can write as 1 divided by 100 multiplied with this 100, and this 10 will come down plus 0, oh sorry, this I can write as 1, this thing I can write as 1 divided by 100 multiplied with this 100 divided by this 0.4. So this is equal to, this will get cancelled with this will get cancelled with this, and this is equal to sorry, here we have one more 0, so here it 110 will come here, so this will get cancelled with this. We left with 1 plus this will get cancelled with this, so here we will get, so 2 divided by 10 which is equal to 0.2 plus, so here I'll get 425, so this will get cancelled with this and I'll get here 2.5. So here if we add all these we'll get to 3.7 percentage. So this is the percentage error in force. So this is my answer. So with this we have completed chapter 1 unit and measurement. Thank you for watching.